Airplanes. These will be the topics discussed. In the 19th century, an English baronet designed a flying machine with fixed wings, a propulsion system, and movable control surfaces. This became the fundamental concept of the airplane. Sir George clearly defined the forces of lift and drag and presented the first scientific design for a wing aircraft. As World War I approached, aircraft have become an essential part of war and peace. Turbofan engines produce a great amount of thrust and make the airplane move forward. Relatively air moving over the wing will produce a lift force on the wings. During takeoff, the flaps and slats of the wing are extended downwards to increase the wing area and curvature of the airfoil. As the curvature increases, air will be more deflected and a greater lift force will result. Finally, when the lift force is more than the gravitational force, the plane takes off. Then during the flight, the flaps and slats are put back into the original position and gravity force balances lift force. Here is an image of the scanning electron microscopy of a jet engine fracture.
Airplanes were originally made of durable, shock-resistant wood such as spruce, ash, and plywood covered in fabric. The first metal airplane, the Ford Trimotor, was constructed in 1925 and was composed of aluminum alloys, which are metals comprised of at least 85% aluminum with traces of copper, manganese, magnesium, and other elements to increase strength but maintain the lightweight. Then, in 1964, titanium and steel were introduced to the aircraft industry to provide greater tensile strength and resistance to corrosion. The latest innovation in aircraft technology is the use of composite materials, which are mixtures of resins reinforced with fibers made of glass or carbon. The steel in airplanes, which comprises around 10% of the total materials, is mostly iron with varying amounts of carbon, nickel, and chromium. Titanium and aluminum, the next most prevalent metals, are essential in that they have high strength-to-weight ratios, are resistant to corrosion, and have high temperature and fatigue resistance. Composites such as carbon epoxies and glass fiber reinforced plastics are becoming popular materials in aircraft due to their low densities, high strengths, and high flexibilities. They are expensive to manufacture, though, and it is hard to find their fatigue points, putting them at risk for unexpected stress damage. Aluminum alloys may be the future of aircraft engineering, since new alloys such as titanium aluminide, nickel aluminum, and lithium aluminum are proving to be less dense, cheaper to manufacture, and more resistant to fatigue than other alloys. Materials such as these and carbon-based composites are light in weight, strongest, and most resistant to heat and corrosion, and therefore will decrease fuel consumption, optimize safety, and decrease susceptibility to damage.
Airplanes contain many aluminum alloys, such as aluminum alloy 2024, which is also found in truck wheels, orthopedic equipment, and clock parts. They have a history that dates back to ancient Rome, with the use of aluminum-based salts. However, Hans Christian Oersted produced the first aluminum alloy in 1825. They were first introduced in airplanes in 1903 when the Wright brothers replaced the heavy car engine in their Flyer 1 aeroplane with lightweight aluminum parts. Duralumin is another aluminum alloy invented in 1909 that was essential for the construction of planes in World War I, and even more alloys were invented in World War II to improve aircraft design. Aluminum alloys are most commonly found in aircraft structures and other applications that require a high strength-to-weight ratio and fatigue resistance, as seen in the shipbuilding industry, the aerospace industry, and building construction. Aluminum alloys are made by mixing liquid aluminum with other elements of the alloy, such as iron, magnesium, or zinc. The principal alloy in aluminum 2024 is copper.
Moreover, aluminum has had a huge commercial and economic impact on the world. The aluminum industry alone contributes $174 billion a year to the U.S. economy, making it 1% of the country's GDP. Aluminum industry also creates a lot of jobs, with more than 162,000 workers who are directly employed by the aluminum industry. Aluminum recycling also creates economic value. Recycling of aluminum saves more than 90% of the cost required in primary production. Aluminum is also 100% recyclable, making the metal one of the most recyclable of all materials. In 2008, the stock market crashed, which caused an overproduction of aluminum, which caused a 50% drop in aluminum prices and the closure of many aluminum smelters. Aluminum industry grew back in 2013, and by 2023, aluminum demand is expected to exceed 80 million tons. A special, interesting, unique characteristic of aluminum is that it is the material of which America's favorite beverage container, the aluminum can, is made from, and it is actually made by multiple alloys. The shell of the can is composed of 3004, and the lid is made from 5182. Sometimes it takes more than one alloy to make one everyday item. These are references. Thank you very much for watching.